The universe is full of mysteries, but every once in a while, something appears that completely breaks our understanding of space. In 2017, astronomers spotted a strange object moving through our solar system at incredible speed. It wasn't a comet. It wasn't an asteroid. And it didn't behave like anything we had ever seen before. They named it Oumuamua, a visitor from another star system, a mysterious object that traveled for millions, maybe even billions of years through interstellar space, before briefly passing through our cosmic neighborhood. But what exactly was it? A natural object shaped by unknown cosmic forces, or something far more unusual? Tonight on Stellar Depth, we explore the strange story of the first known interstellar object ever detected in our solar system. And if you enjoy uncovering the deepest mysteries of the universe, make sure to subscribe to Stellar Depth, because space still hides secrets far beyond our imagination. The day the universe sent us a visitor. For centuries, humanity believed the solar system was a closed neighborhood, a cosmic home surrounded by distant stars, but largely isolated from the rest of the galaxy. Asteroids came from the asteroid belt. Comets traveled from the distant Oort cloud. Every object we observed had one thing in common. They were born here. But in October 2017, something appeared in our telescopes that did not belong. At first, the discovery seemed routine. On the night of October 19th, 2017, astronomer Robert Werik was working with data from the Pan-STARRS 1 telescope in Hawaii. The telescope scans the sky every night, searching for moving objects, asteroids that might pass near Earth, distant comets entering the inner solar system, or anything unusual drifting through space. Thousands of objects are discovered this way every year, but this one immediately stood out. Werik noticed a faint point of light moving against the background stars. That part was normal. But when astronomers began calculating its orbit, something strange appeared in the data. Its path didn't look like the orbit of an asteroid. It didn't look like the orbit of a comet either. In fact, it looked impossible. Most objects in the solar system follow elliptical orbits around the sun. Even long-period comets that arrive from the outer edges of the solar system still remain gravitationally bound to the sun. But this object was different. Its trajectory was hyperbolic. That meant one thing. It was not orbiting the sun at all. Instead, it was simply passing through. Imagine throwing a rock past a planet so fast that gravity cannot capture it. The rock curves slightly as it flies by, but then it continues on its way into deep space forever. That was exactly what this mysterious object was doing. When astronomers traced its path backward, the conclusion was astonishing. This object had come from outside our solar system. For the first time in human history, scientists had detected an object that originated in another star system. A true interstellar visitor. Naturally, astronomers around the world immediately turned their telescopes toward it. But there was a problem. They had discovered it late. By the time it was detected, the object had already passed its closest point to the sun, called perihelion, weeks earlier. It was now speeding away from the solar system at an enormous velocity, and it was moving fast, very fast. At the moment of discovery, the object was traveling at roughly 87 kilometers per second, relative to the Sun. That's about 315,000 kilometers per hour. At that speed, it would cross the distance between Earth and the Moon in less than 2 hours. Even worse for astronomers, the object was already leaving the inner solar system. With every passing day, it became fainter and harder to observe. Scientists had only a small window of time to study it before it disappeared forever. Still, telescopes around the world raced to collect as much data as possible. Observatories in Chile, the Canary Islands, Hawaii, and Arizona began tracking the strange visitor. Each telescope added new pieces to the puzzle, and the more they observed it, the stranger it became. The first mystery was its brightness. As the object rotated, its brightness changed dramatically. Sometimes it appeared relatively bright, then suddenly it dimmed by a factor of 10. This type of brightness variation usually means one thing: the object is very elongated. Imagine a long cigar-shaped rock spinning in space. When its narrow edge faces Earth, it reflects very little sunlight. But when its long side faces us, it reflects much more light. By measuring these brightness changes, astronomers estimated that the object might be 10 times longer than it is wide. Nothing like that had ever been seen before. Most asteroids are irregular chunks of rock. Some are roughly spherical. Others look like potatoes or broken fragments. But this object seemed incredibly stretched, like a cosmic needle drifting through space. Some estimates suggested it might be 400 meters long, but only 40 meters wide. A shape so unusual that scientists initially struggled to explain how it could form naturally. But the shape was only the beginning of the mystery. Next came the color. When astronomers analyzed the light reflected from its surface, they discovered that the object had a reddish tint. This deep red coloration is often seen on objects that have spent millions or billions of years exposed to cosmic radiation. Over time, high-energy particles from space alter the surface chemistry of rocks and ice, creating a dark red crust. This suggested something remarkable. The object had probably been traveling through interstellar space for an incredibly long time, perhaps hundreds of millions of years, maybe even billions. It had wandered through the cold darkness between stars long before humanity ever existed, long before Earth even had complex life. And now, by pure cosmic coincidence, it had passed through our solar system during the brief moment humans possessed telescopes capable of seeing it. But even with all these discoveries, astronomers still had one basic question. What exactly was it? At first, scientists assumed it must be a comet. After all, comets are icy bodies that often originate far from the Sun. If something came from another star system, it made sense that it might resemble the comets we see here. But comets usually have a very obvious feature: a coma, a glowing cloud of gas and dust that forms when sunlight heats their icy surface. Yet when astronomers pointed powerful telescopes at the object, they saw nothing. No coma, no tail, no visible gas. It looked completely inactive. That suggested it was not a comet. Instead, it appeared more like an asteroid, a dry, rocky body without significant ice. But that raised another problem. Asteroids are usually formed in the inner regions of planetary systems. If this object had formed around another star, How could it have been thrown into interstellar space? And how had it survived the journey? These questions puzzled astronomers across the world. The object was clearly alien to our solar system. Yet it did not behave exactly like anything we had seen before. As scientists continued analyzing the data, the International Astronomical Union needed to officially classify the strange visitor. Since it didn't fit the normal categories of asteroid or comet, they created an entirely new classification. Interstellar object, and they gave it a name from the Hawaiian language, chosen to honor the telescope that first discovered it. Oumuamua. Roughly translated, the name means a messenger from afar arriving first. A perfect description for something that had traveled across the galaxy, only to briefly visit our tiny corner of space. But as astronomers soon discovered, the messenger from afar carried a mystery far deeper than anyone expected. Because the more scientists studied Oumuamua, the less it made sense. And some researchers began asking a question that would spark one of the most controversial scientific debates of the decade. What if Oumuamua wasn't just a rock? A visitor moving too fast. By the time astronomers around the world began studying Oumuamua, the mysterious object was already leaving the inner solar system. Every hour it moved farther away from the Sun and from Earth, and that created a race against time. Scientists only had a few weeks, maybe a couple of months, before the strange visitor would fade beyond the reach of even the most powerful telescopes on Earth. Every night, observatories rushed to collect as much data as possible. But one of the first things astronomers needed to understand was its speed. Because if Oumuamua truly came from another star system, its motion through space should reveal that story. And the numbers were astonishing. Even before entering our solar system, the object was already moving extremely fast, about 26 kilometers per second relative to the Sun. That speed alone was a major clue. Objects born inside our solar system usually travel at speeds that reflect the Sun's gravitational pull. But Oumuamua was already moving too quickly for that to be the case. It had arrived with its own momentum, carrying the velocity of another star system. Then something interesting happened. As it approached the Sun, gravity pulled the object inward, accelerating it even further. Like a stone falling toward Earth, its speed increased as it dove deeper into the Sun's gravitational well. By the time it passed closest to the Sun, on September 9th, 2017, it was traveling nearly 87 kilometers per second. That's more than 300,000 kilometers per hour. But the most fascinating detail wasn't just how fast it moved. It was how its path curved through space. Most comets that enter the solar system follow elongated elliptical orbits. They loop around the Sun and eventually return again, sometimes thousands of years later. But when astronomers plotted the trajectory of Oumuamua, the curve looked completely different. Instead of an ellipse, it followed a hyperbolic path. In simple terms, that means the object came in from deep space, bent slightly as the Sun's gravity pulled on it, and then escaped forever. Like a cosmic slingshot. The Sun would never see it again. And when scientists traced the path backward into the past, they realized something remarkable. Oumuamua had entered our solar system from a direction near the constellation Lyra, but it did not come from any specific star currently located there. Instead, it had likely been traveling through the galaxy for hundreds of millions of years. Stars move, solar systems drift. Over such enormous periods of time, the original home star that ejected Oumuamua could have traveled thousands of light years away. The object had essentially become a galactic wanderer, a fragment of some distant planetary system, thrown into interstellar space long ago. But how does something like that even happen? To answer that question, scientists turned to computer simulations. In the early stages of a planetary system's formation, chaos dominates. Young planets collide with one another. Massive gas giants migrate through their orbits. Gravity throws smaller bodies in every direction. During this violent period, countless asteroids and icy planetesimals can be ejected entirely from the system. Imagine a small rock passing too close to a giant planet like Jupiter. The planet's gravity can act like a slingshot, accelerating the rock to incredible speeds, sometimes fast enough to escape the star's gravity forever. In fact, this process probably happened many times in our own solar system. Billions of years ago, Jupiter and Saturn may have thrown trillions of icy objects into deep space. Those objects would have wandered the galaxy endlessly, and the same process likely happens in planetary systems everywhere, which means something incredible. The Milky Way galaxy may be filled with trillions upon trillions of interstellar objects drifting silently between the stars, invisible, cold, lost. Every once in a while, one of them passes through another star system, and in 2017, one passed through ours. But even though scientists believed Oumuamua was probably a natural object ejected from another planetary system, many questions remained. For example, why didn't it behave like a normal comet? Comets are made of ice, dust, and frozen gases. When they approach the sun, the heat causes those materials to evaporate, producing a bright coma and long tail. But Oumuamua showed no visible tail at all. That suggested it might not contain much ice. Perhaps it was more like an asteroid, a rocky body formed closer to its parent star. But if it were a rocky asteroid, then another puzzle appeared. How did such an object survive the immense violence of planetary ejection? Many asteroids that collide with planets or experience powerful gravitational interactions break apart into fragments. Yet, Oumuamua appeared to be intact. Even stranger, it had an extremely unusual shape. As astronomers continued analyzing its brightness variations, they discovered the object rotated once every about 8 hours. But its brightness changed by a factor of 10 during that rotation. That is an enormous variation. Such dramatic changes suggested an object far more elongated than typical asteroids. Some early models suggested a cigar-shaped body nearly 10 times longer than it was wide. Others proposed something even stranger, a flat, pancake-like shape. Both possibilities were extraordinary. No known asteroid in our solar system had ever shown such extreme proportions. But there was still another mystery waiting to be discovered. One that scientists would only notice after carefully tracking the object's movement through space. Because as astronomers monitored Oumuamua over time, they noticed something subtle, something unexpected. The object wasn't moving exactly the way gravity predicted it should. At first, the difference was extremely small, barely measurable. But as the data accumulated, researchers realized the object was experiencing a slight additional acceleration. In other words, something was pushing it. Very gently, very slowly, but consistently. The acceleration was tiny, only about 1/5000th of Earth's gravitational pull. Yet, in space, even a tiny force can change the motion of an object over time. And that raised an important question. What could be causing it? The most obvious explanation seemed simple. Comets often experience non-gravitational acceleration when gas escapes from their surfaces. As sunlight heats the ice, jets of vapor act like miniature rocket engines, pushing the comet slightly off course. But if that were happening with Oumuamua, astronomers should have seen gas or dust escaping from the object. Yet even the most sensitive telescopes detected nothing. No visible jets, no dust cloud, no tail. The object appeared completely inert. And that left scientists with a growing mystery. Something was accelerating the interstellar visitor, but no one could see what it was. At first, many researchers assumed the acceleration must still be caused by some kind of outgassing that simply wasn't visible. Perhaps the object released gases that were difficult to detect with Earth-based telescopes. Maybe hydrogen, or nitrogen, or some exotic form of frozen material. But the deeper scientists looked into the data. The stranger the situation became. Because the amount of force needed to create the observed acceleration implied a level of gas activity that should have been obvious. And yet, there was still no sign of it. The visitor from another star system had arrived silently. It showed no comet tail, no jets, no debris. And yet something invisible seemed to be pushing it through space. By late 2017, the mystery of Oumuamua had begun attracting enormous attention in the scientific community. Dozens of research teams analyzed the data. Papers were written. Debates started. And some scientists began exploring explanations that sounded almost impossible. Because if the acceleration wasn't caused by gas, then what else could push an object through space? One possibility involved radiation pressure, the tiny force exerted by sunlight itself. Photons from the sun constantly strike objects in space, transferring small amounts of momentum. Normally, this force is far too weak to affect large objects like asteroids. But if an object were extremely thin, or extremely light, sunlight might be able to push it. And that idea led to one of the most controversial suggestions ever proposed about Oumuamua. A suggestion that would ignite debates across the entire world of astronomy, because some scientists began wondering whether the strange visitor might not be a natural object at all. Instead, it might be something else entirely. The shape no one expected. By late 2017, astronomers had gathered as much data as possible on the mysterious visitor known as Oumuamua. But the more scientists analyzed the observations, the stranger the object appeared. One of the biggest mysteries was its shape. Because unlike planets or most asteroids, Oumuamua didn't seem round, or even roughly irregular like a typical space rock. Instead, it appeared extremely elongated. Astronomers discovered this by studying how its brightness changed over time. When a distant object spins in space, the amount of sunlight it reflects toward Earth varies depending on which side is facing us. If the object is spherical, the brightness remains relatively constant. But if the object has an uneven shape, the brightness can fluctuate dramatically. With Oumuamua, those fluctuations were enormous. As it rotated, its brightness increased and decreased by a factor of 10. That is far larger than what astronomers usually see with asteroids. To understand why this mattered, imagine a simple example. If a long object like a pencil spins in sunlight, sometimes we see its long side, reflecting a lot of light. Other times we see only its narrow edge, reflecting very little. This causes the brightness to change dramatically. And based on the data, scientists estimated that Oumuamua might be 6 to 10 times longer than it is wide. That suggested an incredibly unusual structure. Some early models proposed a cigar-shaped object, perhaps around 400 meters long but only 40 meters wide. Others suggested something even stranger, a flat, disc-like body, almost like a cosmic pancake. Both possibilities were extraordinary. No object with such extreme proportions had ever been observed before in our solar system. But the mysteries didn't stop there. When astronomers analyzed the rotation of Oumuamua, they found something equally unusual. Most asteroids rotate in a stable way, spinning smoothly around a single axis, like a top. But Oumuamua appeared to be tumbling through space. Instead of rotating cleanly, it was wobbling unpredictably as it traveled. This type of motion is called non-principal axis rotation, sometimes described as chaotic tumbling. Imagine throwing a book into the air and watching it spin unevenly in different directions. That seemed to be exactly what Oumuamua was doing. And that raised another fascinating possibility. Objects that tumble like this often experienced a violent collision in the past. Perhaps long ago, before it ever entered our solar system, Oumuamua had been struck by another object in its original planetary system. The impact might have sent it spinning uncontrollably and eventually ejected it into interstellar space. But even that explanation raised more questions. Because if the object had suffered a violent collision, how had it survived intact? With such an unusual shape, scientists expected it to break apart easily. Yet it appeared to be a single, solid body. And the more researchers studied the data, the more they realized something else. The surface of Oumuamua seemed extremely dark. It reflected only about 10% of the sunlight that struck it, similar to charcoal. This dark coloration suggested the object had been exposed to cosmic radiation for an incredibly long time. In deep interstellar space, there is no atmosphere, no magnetic field, and no shielding from energetic particles. Over millions or billions of years, radiation slowly alters the chemistry of an object's surface. Ice becomes darker, organic molecules form, and the outer layers turn reddish or brown. That matched what astronomers were seeing. Oumuamua's reddish color strongly suggested it had been wandering through interstellar space for a very long time. But another mystery soon appeared, because when scientists tried to model its shape more precisely, they discovered something unusual about its brightness curve. The brightness changes did not match the simple rotation of a cigar-shaped object. Instead, the pattern suggested a more complex geometry. Some researchers proposed that the object might actually be flat and thin, rather than long and cylindrical. In other words, it might resemble something closer to a disk or sheet. If that were true, It would explain some of the unusual brightness patterns seen by telescopes. But a thin disk raised an even more puzzling question. How could such an object survive billions of years, drifting through interstellar space without breaking apart? Even tiny collisions with dust particles could damage extremely thin structures. Yet, Oumuamua had apparently survived the journey. This led scientists to consider the possibility that the object might be much stronger than typical comets or asteroids. Perhaps it was made of dense rock. Or perhaps it was composed of exotic materials formed in extreme environments. But there was still another puzzle, one that would soon become the center of an intense scientific debate. Because when astronomers continued tracking the object's motion, they confirmed something remarkable. Oumuamua was accelerating slightly as it moved away from the sun. At first glance, this behavior looked similar to what happens with comets. When sunlight heats a comet's icy surface, jets of gas erupt outward. These jets create small thrust forces that alter the comet's trajectory. But again, there was a problem. Even the most powerful telescopes, including the Hubble Space Telescope, could not detect any visible gas or dust escaping from Oumuamua. No comet tail, no plume, no debris. The object appeared completely inactive, and yet it was still accelerating. That forced scientists to explore alternative explanations. Some suggested the object might be releasing hydrogen gas, which is extremely difficult to detect. Others proposed that it might contain nitrogen ice, similar to the frozen surface of Pluto. In this theory, sunlight heating the nitrogen could create invisible gas jets without producing dust. But even these explanations were controversial, because the observed acceleration required a surprisingly large amount of gas activity, enough that astronomers expected at least some trace of it to be visible. Yet nothing appeared. The deeper scientists examined the data, the more unusual the situation became. Eventually, one of the most famous and controversial ideas about Oumuamua emerged. In 2018, Harvard astrophysicist Avi Loeb and researcher Shmuel Bialy published a paper proposing a radical possibility. They suggested that the mysterious acceleration might be caused by radiation pressure from sunlight. In other words, photons, particles of light. Striking the object might be pushing it slightly as it traveled through space. This effect is real. In fact, engineers have proposed using solar sails for spacecraft, thin, reflective sheets that use sunlight as propulsion. But for radiation pressure to noticeably accelerate Oumuamua, the object would need to have a very unusual property. It would need to be extremely thin and lightweight, almost like a sheet. And that raised a provocative question. If Oumuamua were thin enough to be pushed by sunlight, could it be something like a solar sail? Perhaps even artificial? The idea quickly spread across the scientific world. Some researchers dismissed it immediately. Extraordinary claims require extraordinary evidence, and there was no direct proof that Oumuamua was anything other than a natural object. But others argued that the unusual data could not be ignored, because nothing quite like this object had ever been observed before. It had no comet tail, no visible gas, an extreme shape, and a mysterious acceleration. For a brief moment, the scientific community found itself confronting a question that had once belonged only to science fiction. What if the first interstellar object humanity ever detected was not just a rock? What if it was a relic of technology built by another civilization? Most astronomers remained skeptical, but the debate had begun. And as new theories emerged, scientists around the world continued searching for a natural explanation that could solve the puzzle of the strange visitor. Because somewhere out in the darkness between stars, objects like Oumuamua might be far more common than anyone ever imagined. And if that was true, then our solar system might not be as isolated as we once believed. The acceleration that shouldn't exist. By the time scientists finished analyzing the first wave of observations, one thing had become clear. Oumuamua did not behave like a normal object. Its strange shape was unusual. Its tumbling motion was rare. But the most puzzling detail of all was its unexpected acceleration. When astronomers track an object in space, they calculate exactly how gravity should affect its motion. The sun's gravity pulls objects inward. Planets slightly alter trajectories. But once these gravitational forces are accounted for, the path of the object should become predictable. Yet when researchers tracked Oumuamua carefully, something didn't match. The object was moving slightly faster than gravity alone could explain. At first, the difference was tiny, but over time the deviation became undeniable. Something was giving the object a small push away from the sun. And in space, even a tiny push matters. The acceleration measured was extremely small, about 0.0000005 meters per second squared. That might sound insignificant, but across millions of kilometers it was enough to alter the object's trajectory measurably. The most obvious explanation seemed simple. Comet outgassing. When a comet approaches the sun, heat causes ice on its surface to evaporate into gas. These escaping gases act like miniature rocket engines, pushing the comet slightly. This effect is well known and commonly observed. But Oumuamua presented a major problem. If gas were escaping from its surface, telescopes should detect a visible cloud of dust or vapor surrounding the object. Astronomers looked carefully. They searched with some of the most powerful instruments available. Yet they found nothing. No coma, no tail, no dust. Even the Hubble Space Telescope detected no sign of gas. It was as if the object were completely inert. Yet somehow, it was still accelerating. This forced scientists to explore other possibilities. One idea was that the gas being released was something extremely difficult to detect. Hydrogen, for example, is nearly invisible in space. If Oumuamua contained large amounts of frozen hydrogen, sunlight could cause the hydrogen to evaporate without leaving a visible trace. But that explanation had problems too. Hydrogen ice is extremely fragile. Over long journeys through interstellar space, it should slowly evaporate even in the cold darkness between stars. If Oumuamua had spent millions or billions of years traveling between star systems, hydrogen ice likely would not survive the trip. Another idea suggested the object might contain nitrogen ice. In 2021, some scientists proposed that Oumuamua could actually be a fragment of a Pluto-like world. On Pluto and similar icy bodies, nitrogen ice covers large portions of the surface. If a collision shattered such a world, fragments of nitrogen ice might be ejected into space. As those fragments approached another star, the nitrogen could sublimate, turning directly from solid into gas. This gas could create the observed acceleration without producing large amounts of dust. It was a clever theory. But again, problems appeared. Computer models suggested that fragments of nitrogen ice large enough to reach our solar system would be extremely rare. And if such fragments were common, astronomers should have detected many more objects, like Oumuamua, but they hadn't. So the mystery remained. What was pushing the interstellar visitor? Then another explanation emerged. An explanation based not on gas, but on light itself. Sunlight might seem gentle, but it actually carries momentum. Photons, the particles that make up light, can transfer tiny amounts of force when they strike an object. Normally, this force is incredibly weak. For large objects like asteroids, the effect is almost completely negligible. But if an object were extremely thin and lightweight, sunlight could push it more noticeably. Engineers have long proposed using this phenomenon for space travel. The idea is known as a solar sail. A spacecraft equipped with a giant reflective sheet could use sunlight as propulsion. No fuel required. Just the pressure of photons. When researchers calculated the acceleration acting on Oumuamua, they discovered something intriguing. The numbers were consistent with radiation pressure, if the object had a very low mass relative to its surface area. In other words, if it were thin, extremely thin. Some calculations suggested that a sheet only a fraction of a millimeter thick could experience exactly the type of acceleration observed, and that led to one of the most controversial ideas ever proposed in astronomy. If Oumuamua were a thin sheet pushed by sunlight, could it be something like a solar sail? Not built by humans, but by another civilization. The idea was proposed by astrophysicist Avi Loeb, who argued that the object's properties were difficult to explain using conventional natural models. Loeb did not claim that aliens had definitely built Oumuamua, but he suggested that the possibility should be considered seriously because the data appeared unusual, very unusual. The scientific community reacted quickly. Some researchers found the idea intriguing. Others rejected it outright. Most scientists prefer natural explanations unless overwhelming evidence suggests otherwise. Extraordinary claims require extraordinary evidence, and in this case, the evidence was still limited. After all, astronomers had only a few weeks of observations. Oumuamua had already disappeared into the darkness beyond our telescopes, but the debate sparked intense interest across the world. For the first time, scientists were seriously discussing the possibility that the first interstellar object ever detected might represent something far more mysterious than a rock. Still, most researchers continued searching for natural explanations, because the universe often produces strange phenomena without any need for intelligent design. And if Oumuamua were natural, then somewhere in the galaxy there must be processes capable of producing objects far stranger than anything we had ever imagined. But one thing was certain. The discovery of Oumuamua had changed astronomy forever, because it proved something remarkable. Objects from other star systems do pass through our solar system, and if one appeared in 2017, others would eventually follow. The question was no longer if we would see another interstellar visitor. The question was when, and when the next one arrived, scientists would be ready. Visitors between the stars. For most of human history, the space between stars seemed empty. Astronomers knew that the galaxy contained enormous distances, vast regions of cold darkness, separating one solar system from another. But the discovery of Oumuamua revealed something extraordinary. Interstellar space might not be empty at all. Instead, it could be filled with countless wandering objects, fragments of planetary systems, lost debris drifting through the Milky Way. When scientists began modeling how planetary systems form, they realized something surprising. During the early stages of planet formation, gravitational chaos dominates. Young planets collide. Massive gas giants migrate through unstable orbits, and smaller objects, asteroids, comets, icy bodies, are constantly thrown around by powerful gravitational forces. Sometimes those forces are strong enough to eject objects completely from the system. Imagine a small, icy body passing close to a giant planet like Jupiter. The planet's gravity acts like a cosmic slingshot. The object accelerates rapidly, and if it gains enough speed, it escapes the star's gravity entirely. Once that happens, the object becomes a rogue traveler, no longer bound to any star. It drifts through the galaxy alone, and this process is not rare. In fact, simulations suggest it happens billions of times during the formation of a single planetary system. If even a small fraction of those objects escape, the Milky Way could contain trillions upon trillions of interstellar fragments. Tiny pieces of distant worlds floating silently between stars. Most of them are probably impossible to detect. They are small, cold, and incredibly dark. But occasionally, by pure chance, one of them passes through another solar system. And when that happens, it briefly becomes visible. Oumuamua was the first such object humans had ever detected, but it would not be the last. In fact, just 2 years later, astronomers discovered another interstellar visitor. This one was very different. In 2019, scientists detected a comet now known as 2I/Borisov. Unlike Oumuamua, Borisov looked exactly like a normal comet. It had a bright tail, a visible coma, jets of gas and dust streaming into space. It behaved exactly the way astronomers expected. And that made it easier to understand. Borisov was likely an icy comet formed in another star system, ejected during the early chaos of planetary formation. But the discovery of Borisov also highlighted something interesting. If most interstellar objects resemble comets, then why did Oumuamua look so different? Why did it appear inactive? Why did it lack a visible tail? Why did it accelerate without obvious gas emissions? Those questions continued to puzzle researchers, but one thing was becoming clear. Interstellar visitors were real. And as telescope technology improved, astronomers would likely discover many more. One of the most exciting future instruments is the Vera C. Rubin Observatory in Chile. This massive telescope will scan the entire sky repeatedly, detecting faint, moving objects with unprecedented sensitivity. Scientists expect it could discover dozens of interstellar objects every year. Some might be small fragments, like Oumuamua. Others might be large comet-like bodies like Borisov. And with more observations, astronomers could finally begin understanding how common these objects really are. But there is another exciting possibility. If astronomers detect an interstellar object early enough, humanity might attempt something extraordinary. We might send a spacecraft to intercept it. Imagine a probe racing through space to meet a visitor from another star system, a fragment of a distant world, a sample of material that formed around a completely different star. Such a mission would represent one of the most ambitious scientific projects ever attempted, and scientists have already begun studying how it might work. Some mission concepts propose using powerful rockets or solar sails to chase future interstellar objects. Others suggest building spacecraft that wait in space, ready to launch toward the next visitor the moment it appears. Because if we can reach one of these objects, we could learn incredible things. What elements exist in other planetary systems? How similar are they to our own? Did planets around other stars form the same way ours did? And perhaps the most fascinating question of all, what secrets might these wandering messengers carry with them? Oumuamua may have already vanished into the darkness beyond our telescopes. It is now racing away from the sun at incredible speed. Eventually, it will leave the solar system entirely. And once again, it will become a lonely traveler drifting through the galaxy. Perhaps millions of years from now, it will pass another star. Maybe another civilization will see it. Maybe they will study it the way we did, and they too will wonder where it came from. For now, the mysterious visitor has left behind more questions than answers, but its brief appearance taught humanity something profound. Our solar system is not isolated. The galaxy is alive with wandering objects, and every once in a while, one of them finds its way to us. The message from the dark, between stars. By the time the last observations of Oumuamua were completed, the mysterious visitor was already disappearing into the outer darkness of the solar system. Each passing week made it fainter. Soon, it became impossible for even the most powerful telescopes on Earth to detect it. Within a few months, it was gone. The object continued racing outward, escaping the sun's gravity forever. Eventually, it would pass beyond the distant Oort cloud and return to the vast emptiness between the stars. And there, it would continue its lonely journey across the Milky Way. Perhaps for millions of years, perhaps for billions. But even though Oumuamua vanished from view, the scientific questions it left behind remained. Because its brief visit forced astronomers to rethink something fundamental about our galaxy. For decades, scientists assumed that detecting objects from other star systems would be extremely rare. The distances between stars are enormous. The chances of a small object passing through our solar system seemed incredibly small. Yet Oumuamua appeared anyway. And once astronomers ran the numbers, something surprising emerged. For us to detect an interstellar object so quickly after developing powerful sky surveys like pan-stars, there must actually be many more objects like it passing through the solar system all the time. Most of them are simply too small or too faint for current telescopes to see. But statistically, our solar system may be visited by thousands of interstellar objects every year, tiny fragments of distant worlds silently crossing our cosmic neighborhood. Most of them arrive unnoticed. Most of them leave without anyone ever realizing they were here. But occasionally, one becomes visible, and when that happens, we are given a rare opportunity, a chance to study matter that formed around another star. In some ways, Oumuamua represented something like a cosmic message in a bottle. Not a deliberate message, but a natural one. A fragment of another planetary system carrying clues about environments far beyond our own. Even though we never got close enough to study it directly, scientists still learned valuable information from the brief observations they captured. For example, its reddish color suggested the presence of complex organic molecules on its surface. These molecules form when simple carbon compounds are exposed to radiation over long periods of time. Such chemistry occurs throughout the universe. Comets, asteroids, and icy bodies often contain organic material created by cosmic processes. This means something remarkable. The building blocks of life, carbon-based molecules, may be extremely common across the galaxy. Fragments like Oumuamua could carry these materials from one star system to another. In fact, some scientists believe that interstellar objects might play a role in spreading organic chemistry between planetary systems, a concept sometimes called panspermia. The idea suggests that microscopic life, or the ingredients needed for life, could travel between stars on objects like comets or asteroids. Over millions of years, these wandering bodies could seed planets with organic material. It's still only a hypothesis. But discoveries like Oumuamua make the idea seem slightly less impossible. Because if objects truly travel between star systems, then the galaxy may be far more interconnected than we once imagined. But beyond scientific theories, the discovery of Oumuamua also changed how astronomers think about exploration. For the first time, humanity realized something extraordinary. Objects from distant star systems are accessible, not easy to reach, but potentially reachable. With the right technology, a spacecraft could intercept one of these visitors. And if that happened, the scientific payoff would be enormous. Imagine collecting samples from a fragment of a planet that formed around another star. Imagine analyzing its chemistry, its minerals, its isotopes. We could compare it directly with material from our own solar system. It would be like opening a geological time capsule from another world. Scientists have already begun studying how such missions might work. One concept proposes a spacecraft waiting in orbit around the Sun, ready to launch toward the next detected interstellar object. Another idea involves solar sail spacecraft, capable of accelerating rapidly using sunlight. These missions could potentially catch up with fast-moving visitors like Oumuamua, but timing would be critical. Astronomers must detect the object early enough, and that's where the future of astronomy becomes incredibly exciting. Within the next few years, a new telescope will begin scanning the sky with unprecedented power, the Vera C. Rubin Observatory. This enormous telescope will repeatedly image the entire night sky with extraordinary sensitivity. It will detect faint, moving objects that current surveys might miss. Many scientists believe it could discover dozens of interstellar visitors every year. Some may be small fragments, others may be massive comet-like bodies, and one day, perhaps, we might detect one early enough to send a spacecraft. If that happens, humanity could witness one of the most extraordinary scientific missions ever attempted. A rendezvous with a traveler from another star. But even without a spacecraft, the discovery of Oumuamua has already changed how we see our place in the universe. For centuries, humans imagined the solar system as an isolated island in space, a tiny system orbiting a distant star, separated from the rest of the galaxy by unimaginable distances. Yet, Oumuamua proved that these boundaries are not as absolute as we once thought. Objects move between stars. Fragments of distant worlds travel through the galaxy, and every once in a while, one of them passes through our neighborhood. When that happens, we are given a brief glimpse into the cosmic processes shaping planetary systems far beyond our own. The strange visitor of 2017 may have vanished into the darkness, but it left behind something far more valuable than answers. It left us with new questions. How many interstellar objects exist? Where do they come from? What worlds did they once belong to? And what other mysteries might be drifting silently through the vast ocean between the stars? Somewhere out there, another traveler may already be approaching. A silent messenger moving through the galaxy. And perhaps one day soon, humanity will be ready to meet it. Where did Oumuamua come from? Long before Oumuamua entered our solar system, it was part of another world, somewhere in the Milky Way, around a distant star we may never identify. This strange object once belonged to a young planetary system. But how did it leave? How did a piece of matter from another star travel across the galaxy, only to briefly pass through our cosmic neighborhood? To understand that story, astronomers had to look back to the earliest stages of planet formation. When a new star is born, it forms inside a swirling cloud of gas and dust known as a protoplanetary disk. Within this disk, tiny particles begin sticking together. Dust grains collide and form pebbles. Pebbles merge into rocks. Rocks grow into massive bodies known as planetesimals, the building blocks of planets. Over millions of years, gravity pulls these planetesimals together, gradually forming planets. But the process is not gentle. In fact, the early history of a planetary system is incredibly chaotic. Young planets move through unstable orbits. Massive gas giants migrate inward and outward. Countless smaller bodies are constantly thrown into new trajectories. Some collide and merge. Others shatter into fragments, and many are simply ejected into space. This process happens when a small object passes close to a massive planet. Gravity accelerates the object like a slingshot. If the object gains enough speed, it escapes the star's gravitational pull entirely. At that moment, it becomes an interstellar wanderer, no longer bound to its original system, just drifting through the galaxy. Scientists believe this process occurs in nearly every planetary system, which means the Milky Way may be filled with unimaginable numbers of these wandering fragments. Some estimates suggest that for every star in the galaxy, there could be billions of interstellar objects. That means trillions, perhaps quadrillions, drifting silently through the dark. Most are probably tiny, grains of dust, small rocks, but some, like Oumuamua, are much larger, fragments hundreds of meters across, remnants of distant worlds. But determining exactly which star system produced Oumuamua is extremely difficult. Stars themselves are constantly moving through the galaxy. Over millions of years, their positions change dramatically. By the time Oumuamua reached our solar system, its original star might have moved thousands of light years away. Astronomers attempted to trace its path backward through space. Using computer simulations, they calculated the direction from which the object entered the solar system. But the results were frustrating. The object's speed and long journey through interstellar space meant that small uncertainties in its trajectory quickly grew larger over time. After only a few million years of backward simulation, its path became impossible to trace precisely. The cosmic trail simply vanished. However, scientists did learn something interesting about its motion. Before entering the solar system, Oumuamua was moving at about 26 kilometers per second relative to the Sun. That speed closely matches the average velocity of nearby stars in our region of the Milky Way, which suggests that Oumuamua was probably not traveling extremely fast compared to the surrounding stellar population. In other words, it had likely been drifting through the galaxy for a very long time, gradually matching the average motion of nearby stars. This supports the idea that the object might be hundreds of millions or even billions of years old, older than humanity, older than most complex life on Earth, perhaps even older than the dinosaurs. During that immense span of time, the object would have experienced a harsh environment. Interstellar space may seem empty, but it is far from peaceful. High-energy cosmic rays constantly bombard objects traveling between stars. Tiny dust particles occasionally collide with them at enormous speeds. Temperatures plunge close to absolute zero. Over millions of years, these conditions slowly alter the surface of any object drifting through space. Organic molecules darken. Ice becomes chemically transformed, and the outer layers gradually form a tough, radiation-altered crust. Scientists believe Oumuamua likely developed such a crust during its journey. This crust may explain why the object did not show obvious signs of outgassing like a typical comet. If the outer surface became hardened over time, it could trap volatile materials beneath it. Only when the object approached the Sun would heat penetrate deeper layers, possibly releasing small amounts of gas without producing a visible coma. But even this explanation remains uncertain, because despite years of research, no single theory perfectly explains all of Oumuamua's observed properties: its shape, its acceleration, its unusual brightness variations. Each new explanation seems to solve one mystery while creating another, and that uncertainty is part of what makes the object so fascinating, because science often advances through exactly these kinds of puzzles. Moments when observations challenge our assumptions. Moments when nature reveals something unexpected. Oumuamua forced astronomers to confront the fact that planetary systems across the galaxy may produce objects very different from those in our own solar system. Perhaps other star systems form bodies with unusual shapes. Perhaps their comets contain exotic combinations of ice. Or perhaps we simply haven't observed enough interstellar objects yet to understand what is truly common. After all, humanity has detected only 2 confirmed interstellar visitors so far: Oumuamua in 2017, and the Comet 2 I/Borisov in 2019. That is hardly enough data to establish clear patterns, but the situation will change soon. As new telescopes come online, astronomers expect to detect many more interstellar objects. And with each discovery, the mystery will slowly become clearer. Patterns will emerge, theories will be tested, and eventually, scientists may finally understand how objects like Oumuamua form. But perhaps the most profound lesson of this strange visitor is not about the object itself. It's about what its discovery tells us about the galaxy we live in. Because if even one object like this passed through our solar system during the short time humans have been observing the sky, then the galaxy must be full of them, silent travelers moving endlessly between stars, fragments of distant worlds, pieces of cosmic history drifting through the dark. And every once in a while, one of those ancient travelers crosses our path, a reminder that the universe is far larger and far more connected than we once imagined. The debate that shook astronomy. As the data from Oumuamua continued to circulate through the scientific community, the mystery surrounding the strange interstellar visitor only grew deeper. On one side, most astronomers believed that the object must have a natural explanation, something produced by normal cosmic processes that we simply didn't fully understand yet. On the other side, a small number of scientists suggested something far more controversial. They wondered whether the object might not be entirely natural at all. The debate began quietly in late 2018. That was when Harvard astrophysicist Avi Loeb and researcher Shmuel Bialy published a scientific paper examining the unusual acceleration of Oumuamua. Their study focused on the idea that sunlight itself might be pushing the object. As photons from the sun strike a surface, they transfer momentum. This effect is known as radiation pressure. Normally, the force is extremely small, but if an object has a very large surface area compared to its mass, the pressure of sunlight can noticeably influence its motion. Engineers have long proposed using this phenomenon to propel spacecraft. The concept is called a solar sail. A spacecraft equipped with a giant reflective sheet could travel through space using nothing but sunlight. No engines, no fuel, just the gentle pressure of photons. When Loeb and Bialy calculated the acceleration acting on Oumuamua, they discovered something intriguing. The numbers matched exactly what would happen if an object were thin and lightweight enough to be pushed by sunlight. But that raised an astonishing possibility. For sunlight to accelerate the object the way it did, Oumuamua would need to be extremely thin, possibly less than a millimeter thick. And if it were that thin, it might resemble something like a sheet or sail. Loeb suggested that one possibility, however unlikely, was that the object could represent artificial technology created by another civilization. Not necessarily an active spacecraft, perhaps just debris, a broken fragment of an ancient solar sail drifting through space for millions of years. The idea exploded into public attention almost instantly. Headlines around the world began asking the same provocative question: was Oumuamua alien technology? But inside the scientific community, the reaction was far more cautious. Most astronomers did not accept the alien explanation, not because the idea was impossible, but because science demands strong evidence before extraordinary conclusions are accepted. And in this case, the evidence simply wasn't strong enough. After all, astronomers had only observed the object for a few weeks. The data was limited, and natural explanations had not yet been ruled out. In fact, many scientists believed that new discoveries about unusual types of comets or exotic ice compositions could eventually explain the observations. Still, the discussion sparked an important philosophical question in astronomy. How should scientists approach phenomena that appear extremely unusual? Should they ignore extraordinary possibilities entirely? Or should they investigate them carefully, even if the chances seem small? Avi Loeb argued that scientists should remain open to all possibilities, as long as they are consistent with the data. Many of his colleagues agreed with the general principle, but they also emphasized something equally important. Science works best when the simplest explanations are explored first. And in the case of Oumuamua, natural explanations remained far more likely than alien technology. Over the next several years, researchers continued proposing new theories. One suggested that Oumuamua might be made of solid hydrogen ice, which could evaporate invisibly when heated by the sun. Another proposed nitrogen ice, similar to the surface material found on Pluto. Yet another theory suggested that the object might be a porous fragment of cometary material, allowing gases to escape without creating a visible dust cloud. Each idea solved some parts of the mystery, but none of them explained everything perfectly. Even today, scientists continue debating which explanation fits the data best. And that uncertainty is not unusual in science. Many discoveries remain mysterious for years, sometimes decades, before a clear explanation emerges. For example, when astronomers first detected gamma-ray bursts in the 1960s, no one understood what they were. Some scientists even considered the possibility of alien activity. It took more than 30 years before researchers finally discovered that gamma-ray bursts are produced by exploding stars and neutron-star collisions. Nature often turns out to be far stranger than our initial assumptions. And Oumuamua may ultimately prove to be another example of that, a bizarre natural object produced by cosmic processes we are only beginning to understand. But even if the alien hypothesis remains extremely unlikely, the debate surrounding Oumuamua had an important effect. It forced scientists to think more deeply about interstellar exploration. Because if objects truly travel between star systems, then they represent a completely new category of astronomical target, fragments of distant planetary systems passing within reach of our instruments, and, perhaps one day, within reach of our spacecraft. For now, the strange visitor continues its journey through interstellar space. It is already far beyond the orbit of Jupiter. Soon it will pass beyond Neptune. Eventually, it will cross the distant boundary of the solar system and return to the cold darkness between stars. And once again, it will become almost impossible to detect. Just another silent traveler drifting through the galaxy. But its brief visit has already changed our understanding of the cosmos. Because Oumuamua proved that the universe is not as quiet and isolated as we once imagined. Objects travel between stars. Fragments of distant worlds wander through the Milky Way, and every once in a while, one of them finds its way to us, a messenger from another star system, arriving briefly, before disappearing back into the endless darkness of space. The next interstellar visitor. By the time scientists finished studying Oumuamua, one important realization had already changed astronomy forever. The object was not a unique miracle. It was simply the first one we noticed. For billions of years, interstellar objects have almost certainly been passing through our solar system. fragments of distant worlds expelled from their home stars during the violent birth of planetary systems. But until recently, humanity simply lacked the tools to detect them. The sky is vast, and objects like Oumuamua are extremely small, dark, and fast. Even with powerful telescopes, spotting one is incredibly difficult. Yet only 2 years after Oumuamua appeared, astronomers discovered something remarkable: another interstellar object. This time, it looked completely different. In August 2019, amateur astronomer Gennady Borisov was observing the sky from an observatory in Crimea when he noticed a faint moving object. At first, it seemed like a normal comet. But when astronomers analyzed its orbit, they realized something astonishing. The comet had a hyperbolic trajectory, just like Oumuamua. That meant it was not bound to the Sun. It had come from another star system. The object was officially named 2I/Borisov. Unlike Oumuamua, this new visitor behaved exactly like a typical comet. It had a bright, glowing coma, a cloud of gas and dust surrounding the nucleus, and it produced a long, visible tail stretching millions of kilometers into space. Astronomers could easily detect the gases escaping from its surface: water vapor, carbon monoxide, other frozen materials common in comets. In many ways, Borisov looked familiar. It resembled the comets already known in our own solar system. But there were subtle differences. When scientists analyzed the chemical composition of the gases released by Borisov, they found unusual ratios of certain molecules. The comet contained large amounts of carbon monoxide, suggesting it formed in extremely cold regions of its original star system, even colder than the outer reaches of our own solar system. This discovery confirmed something important. Planetary systems around other stars can produce comets very similar to ours. The basic ingredients of planetary formation appear to be common across the galaxy. But the comparison between Borisov and Oumuamua also highlighted just how strange the earlier object truly was. Because while Borisov behaved exactly as expected, Oumuamua did not. Borisov had a visible coma. Oumuamua did not. Borisov showed obvious outgassing. Oumuamua's activity remained mysterious. Borisov looked like a typical comet nucleus. Oumuamua had an extremely unusual shape. These differences raised an important question. Were the two objects part of the same general population of interstellar debris? Or did they represent completely different categories of objects drifting between stars? Scientists still don't know the answer, but the discovery of Borisov proved something crucial. Interstellar objects are not incredibly rare. We simply need better instruments to detect them. And the next generation of telescopes may soon reveal many more. One of the most anticipated instruments is the Vera C. Rubin Observatory, currently being completed in Chile. This enormous telescope will survey the entire night sky repeatedly with extraordinary sensitivity. Every few nights, it will capture deep images of the entire visible sky. By comparing these images over time, astronomers will detect moving objects, asteroids, comets, and possibly many new interstellar visitors. Scientists expect Rubin Observatory could discover dozens of interstellar objects every year. Some might be small fragments like Oumuamua. Others could be massive cometary bodies hundreds or even thousands of meters wide. And with each discovery, we will learn more about the hidden population of objects drifting between stars. But detection alone is not enough. The next step in interstellar science may be even more exciting. Actually visiting one of these objects. For decades, space missions have explored asteroids and comets within our own solar system. NASA's OSIRIS-REx mission even returned samples from the asteroid Bennu. But imagine analyzing material from a completely different star system, a fragment of rock or ice that formed around a distant sun. That would be like holding a piece of another planetary system in your hand. Scientists have already begun designing mission concepts to intercept future interstellar visitors. One idea involves spacecraft equipped with powerful solar sails. These spacecraft could accelerate rapidly using sunlight, allowing them to chase fast-moving objects like Oumuamua. Another concept proposes launching probes that wait in space, ready to intercept the next detected visitor as soon as it appears. If such a mission succeeded, it would mark one of the most extraordinary scientific achievements in human history, because for the first time, humanity would directly study material from another star system. The discovery of Oumuamua and Borisov has opened an entirely new field of astronomy, a field focused on interstellar objects, cosmic travelers carrying fragments of distant worlds, each one a messenger from another part of the galaxy. And somewhere out there, perhaps right now, another visitor is already approaching, moving silently through the darkness, invisible against the background of stars. One day, a telescope will spot it. Astronomers will calculate its trajectory. And once again, humanity will realize that something ancient and mysterious has entered our solar system. A traveler that began its journey long before humans ever looked up at the sky. A fragment of a distant world drifting across the galaxy. And when the next visitor arrives, we may finally be ready to meet it. The messenger that changed our view of the galaxy. When Oumuamua first appeared in the data from the Pan-STARRS telescope in October 2017, astronomers thought they had simply discovered another small asteroid. Within days, they realized they were looking at something far more extraordinary. A traveler from another star. A fragment of a distant planetary system that had wandered through the galaxy for an unimaginable length of time, before briefly crossing the path of our solar system, and then disappearing again into the dark. For a few weeks, humanity had the chance to observe something that had likely been drifting between the stars for hundreds of millions, perhaps billions of years. But the most important legacy of Oumuamua is not the object itself. It is what the discovery revealed about our place in the galaxy. For centuries, humans imagined the solar system as an isolated island in space, a small planetary family orbiting a single star, separated from the rest of the universe by enormous distances. But Oumuamua showed that the boundaries between star systems are not as absolute as we once believed. The galaxy is not divided into perfectly sealed regions. Instead, it is filled with wandering fragments, asteroids, comets, icy bodies, debris from planetary collisions, all drifting silently through the vast darkness between stars. Over millions of years, gravity can send these fragments across incredible distances. Some may travel thousands of light years before encountering another star system, and every once in a while, one of those travelers passes close enough for us to see it. The discovery of 2I/Borisov only 2 years later confirmed that this process is not a rare cosmic accident. Interstellar visitors exist. And as our telescopes improve, we will almost certainly detect many more. Each one will carry clues about environments far beyond our solar system, fragments of planets that formed around distant stars, remnants of collisions that occurred long before Earth even existed. In some cases, these objects may contain chemical materials that formed in entirely different cosmic environments, different temperatures, different radiation conditions, different histories of planetary formation. By studying them, astronomers may learn how other solar systems evolve, how planets form, how debris moves between stars, and perhaps even how the ingredients for life spread through the galaxy. Because if objects like comets and asteroids can travel between star systems, then the chemistry of life might travel with them. Organic molecules, water ice, carbon compounds, all drifting through interstellar space. This idea, sometimes called cosmic exchange, suggests that planetary systems may not evolve completely independently. Instead, they may occasionally share material. Tiny fragments of distant worlds passing silently between stars. The galaxy, in this sense, becomes less like a collection of isolated islands, and more like a vast cosmic ocean where debris slowly circulates over billions of years. But beyond the science, the story of Oumuamua also carries a deeper meaning, because it reminds us that our understanding of the universe is still incomplete. When astronomers first saw the strange visitor, they struggled to explain its shape, its motion, and its unusual acceleration. Even today, scientists continue debating the exact nature of the object. Was it an unusual comet, a fragment of a Pluto-like world, a body made of exotic ice, or something else entirely? We may never know the full answer, because Oumuamua is already far beyond our reach. At this moment, it is racing away from the Sun at more than 90,000 miles per hour. Every second, it moves farther into the darkness beyond the solar system. Eventually, it will re-enter the vast interstellar void, and once again, it will become just another wandering fragment, drifting between stars. Perhaps millions of years from now, it will pass another planetary system, another star, maybe even another civilization. Perhaps somewhere in the distant future, astronomers on another world will notice a strange object entering their sky. They will study its orbit. They will realize it came from another star, and they will wonder where it began its journey. Maybe they will trace its path. Maybe they will discover that long ago, this silent traveler once passed through a small solar system, orbiting an ordinary yellow star, a star we call the Sun. And maybe, just for a moment, they will imagine the brief time when a young civilization on a tiny blue planet looked up at the sky and saw the same mysterious visitor, a messenger from the dark between stars. A reminder that the universe is far larger, far stranger, and far more connected than we ever imagined. And somewhere out there, beyond the reach of our telescopes, another traveler may already be on its way, quietly crossing the vast ocean of the galaxy, waiting for the moment when humanity will see it, and once again realize that we are not alone in the cosmic sea. The traveler that opened a new era, final, long after Oumuamua disappeared from our telescopes, its story continued echoing through the world of astronomy. Because sometimes a discovery is important not only for what it reveals, but for what it changes. And Oumuamua changed something fundamental about how scientists view the galaxy. Before 2017, interstellar objects were mostly theoretical. Astronomers believed they existed, but none had ever been clearly detected. Planetary formation models predicted that countless fragments should be thrown into deep space during the chaotic birth of planets. But predictions are one thing. Seeing proof is another. Then suddenly, one appeared. A mysterious object from beyond our solar system, quietly passing through our cosmic neighborhood. And with that single discovery, the galaxy suddenly felt smaller. Not because distances changed, but because the boundaries between star systems became less absolute. Instead of isolated islands, planetary systems now seemed more like ports along a vast ocean. Fragments of distant worlds drifting from one system to another over millions or billions of years. Each one carrying pieces of cosmic history, each one telling a story about the environment where it formed. The strange visitor of 2017 may have been small, only a few hundred meters long, but its implications were enormous, because it proved that material from distant star systems can reach us. And if we can detect these travelers, one day we may even explore them directly. Already, scientists are discussing missions designed to intercept future interstellar visitors. Fast spacecraft equipped with solar sails, probes waiting in deep space, ready to launch the moment a new object is discovered. These missions could allow humanity to study the composition of another planetary system without traveling to the stars themselves. Instead, the stars may send fragments of their worlds to us, tiny ambassadors crossing the galaxy, cosmic messengers carrying information from distant places we may never otherwise reach. And perhaps someday, one of those messengers will arrive early enough for us to greet it properly, to send a spacecraft, to photograph it up close, to measure its chemistry, maybe even to bring samples back to Earth. If that day comes, it will mark a new chapter in exploration, because it will mean that humanity has begun studying the geology of other star systems, not through telescopes alone, but through direct contact with the objects themselves. Until then, Oumuamua continues its endless journey. It has already passed beyond Neptune. It is moving toward the distant outer boundary of the solar system. Soon, it will cross the invisible frontier where the sun's influence fades into the background of the Milky Way, and then it will vanish into the dark once more. Just another silent traveler drifting through the galaxy. Perhaps it will wander for millions of years before encountering another star. Perhaps it will never again pass close to any planetary system. Or perhaps, somewhere far away in the distant future, another civilization will notice it. A strange object entering their sky. A messenger from another star. And they will ask the same questions we asked. Where did it come from? How long has it traveled? What distant world did it once belong to? But for a brief moment in human history, this ancient traveler crossed paths with us. It appeared in our telescopes. It puzzled our scientists. It challenged our understanding of the universe. And then it continued on its way, a reminder that the galaxy is alive with motion, full of wandering fragments, silent travelers drifting between stars, and somewhere out there, in the vast darkness beyond our solar system, Another one may already be on its way.